another principle. If at all possible, use one variable. Try to avoid multiple variables as often as you can. Hey, there's the first one. There's the second one. What's the third one going to be?
X plus 2.
Very good. Add one more, x plus 2. There's 3 consecutive natural numbers right there. And in fact, if you see 3 consecutive integers, 3 consecutive natural numbers, 3 consecutive whole numbers, it's always going to be x, x plus 1, x plus 2. Right? Now let's come up with our sentence. The sum of 3 consecutive natural numbers is 930. How do I write the sum of those guys? The sum of the 3 consecutive, how do I translate is? Is. Hey, you can have that equation, right? Sure. 3x plus 3. Just get your like terms together. Subtract the 3. Means x must be 3 over 9. And note, and here's where we come to another foundational principle in working word problems. Read the question. Notice what I'm given. The question is, what's the smallest value, what's the largest value, and obviously, what's the other value? So the smallest value is going to be 309. What's the next one going to be?
310.
There you go. And the largest value.
311.
And you'll have lots of time at the end of your test, like you did last time. So just check it out. Make sure those 3 guys add up to 930. Yes?
If you were to take the average of 930 by 3, you come up with 310. Could you just use 310 in the number of the
And go either way?
Yes.
You could. Another way to do it, yes. So if you say what would be the average of those 3 numbers that add up to 910, it'd be 930 would be 310. Smaller, larger, got your 2 numbers. Okay. All right. Brings us to another concept. And that's not this one. It's 4.5, all right? Problem 4.5. Here's the question. Instead of saying the sum of 3 consecutive integers adds up to something, check this out. The sum of 3 consecutive odd integers, or the sum of 3 consecutive even integers, adds up to something. Can somebody give me an example of 3 consecutive even integers? 2, 4, 6. How about 3 consecutive odd integers?
1 through 5.
1 through 5. Okay. You understand what we're talking about, right? So, I'm going to shoot my sharp knife. All right, if you have 3 consecutive integers, it always starts the same way. X, x plus 1, x plus 3. If you have 3 consecutive even integers, I'll give you a hint. The first one is still x,
And x plus 2.
and x plus 2,
X plus 4.
and x plus 4. How about that? Okay? If it says the sum of them, all right, I'll add those up. 3x plus 6 equals something. Okay?
Yeah.
So if it just says 3 consecutive integers, that. 3 consecutive even integers, that. How about 3 consecutive odd integers? I'll go ahead and tell you. The first one's going to be x. What's the next one going to be? I heard x plus 1, x plus the same, x plus 2, and I heard x plus 3.
X plus 1.
Let me go for x plus 1. And you're thinking that, I know what you're thinking. You're thinking that because 1 is an odd number, right? But let me ask you a question. If I look at three consecutive odd integers, what's the difference between those two? And what's the difference between those two?
4.
It's going to be exactly the same. It's going to be exactly the same. I know what you're thinking. You're thinking, hey, isn't that an even number because you're adding 2 to it? What does that depend on if it's an even or odd number? What x is? Sure. If x is odd, then you add 2 to an odd number, you get an odd number. You add 4 to an odd number, you get another odd number. So don't be fooled with the odd or even. If it's odd or even, it's still going to be x, x plus 2, x plus 4. Okay? All right, let's work one that has a, shall we say, a more practical, realistic application. A family has annual loan payments of 37% of their annual income, to which we respond,